Welcome to the project demonstration of sensor-based automatic railway gate controlling system. So nothing but unmanned railway gate controlling based on the sensor inputs. We are using two IR sensors which are used to detect the train arrival and departure. So whenever the train arrives this side, then the sensor will detect that train arriving and it will inform to the PIC microcontroller. We are using PIC 16F72 microcontroller, which will taking care of input from these two IR sensors. When the train detects from this sensor, then the gate will be closes and then it will wait for the another sensor input as it will indicate the train departure successfully. Then the gate will be opens. Same manner, vice versa. If the train arrives from this side, so then it will be considering as a train entering from this side and gate closes, and after train passes away, then gate opens. So the gate opening and closing will be done with help of this 60 RPM 12 volts 5 volts DC motor. So it will get controlling through this L293D motor driver, so which we have interfaced to the C0 C1 pin of our 16F72 microcontroller, and A0 A1 interfaced to this microcontroller as the input to this one, and the whole system getting power supply from this adapter, so which will take 230 volts AC input and provide us a 5 volts DC output. Once we provide that input power supply to this microcontroller, it start reading input from the sensors. So here the main we need to check is, after giving the power supply, only one light should get switched on. So the another light will get switched on whenever the obstacle detects in front of this IR sensor. So initially the gate opens. So when the train arrives, it will be detected by this microcontroller and close the gate. After train passes away, then only the gate opens. So if the train come this side also, right. So here thing is, when we place the object in front of the IR sensor, then only the second light should get switched on. Otherwise, if it is continuously on, there is a obstacle is there in front of the sensor or external sunlight falling on the sensor. So that's why I demonstrate this project opposite of the sunlight. Then we don't get any malfunctions from the sensors. Right.